Hello class, good day sa inyo. So for this video, we shall be discussing the intermolecular forces of attraction. For the learning objectives, so at the end of this discussion, you students should be able to identify the different types of intermolecular forces of attraction, assess the relative strength of the different types of intermolecular forces of attraction, predict the different types of intermolecular forces of attraction existing in a molecule, and lastly, for you to be able to relate the strength of intermolecular forces of attraction with the physical properties. Before we go into the intermolecular forces of attraction or IMFA, let's first appreciate the states of matter that we have. Now, before, nung kayo ay nasa elementary at high school pa, you were told that matter exists in different states. So, nandito yung ating mga solids, liquids, gases. Now, nung medyo mas nag-advance pa yung ating mga discussions, in-include na natin dito yung tinatawag na plasma, okay, and the what is called Bose-Einstein condensates. But for this discussion, we will be focusing on the solids, liquids, and gases lang. And according dito sa slide na to, okay, it is actually possible for you to interconvert these three states of matter. So we can have a liquid to solid transition, solid to liquid, liquid to gas, gas to solid, and so on. At merong kanya-kanyang pangalan ang mga proseso na ito. Now, for the liquid to solid phase transition, we actually call it freezing. Okay? Yung kabaliktaran, solid to liquid, that is melting or fusion. Now, for the case of the liquid to gas phase transition, we call it vaporization. At yung kabaliktaran, gas to liquid, we call it condensation. For the case of the solid gas phase transitions, okay, yung proseso kung saan nag-change tayo ng state from solid to gas is what we call sublimation. At yung kabaligtaran, yung gas to solid, that is what we call deposition. Now, sa ating kapaligiran, meron tayo actually unique molecule na kayang mag-phase transition from solid to liquid or to gas. At yun yung ating water molecule. Now, let's consider the water molecule, okay? Shown here in this slide is the Lewis structure for the water molecule. Alam natin na ang usual form ng water ay in the liquid state, tama? Now, water is actually unique. Why? It is because it can change its phase from liquid to solid and to gas. Now, when liquid water changes to solid form, it becomes ice. And we actually use ice to cool our drinks, especially during the summer season. The fact that we enjoy swimming when we go outing is because of the fact that water exists as a liquid. Okay? Tapos I believe lahat naman tayo siguro nakakain na ng mga steamed foods like siopaw, siomai, and other dumplings, right? Okay? Like I said, they are steamed foods, okay? They were cooked using steam. And steam is actually water existing in the gaseous form. And the fact that we enjoy eating siopaw, siomai, and other steamed foods is because of the fact that water exists as a gas. Now, you may be wondering, ano kaya ang dahilan kung bakit kaya ni water mag-change from liquid to solid or to gas form? The answer is because of the intermolecular forces of attraction. So dito natin i-define formally what is or what are intermolecular forces of attraction or IMFA. Yung ibang students, ang tawag dito ay Imfa. So to formally define, intermolecular forces of attraction or IMFA or Imfa are the forces of attraction existing between or among molecules. So pag sinabing inter, okay, it is between or among. Just like international, okay, between or among nations, intercontinental, okay, between or among continents, intercollegiate, okay, between or among colleges. Okay, and these are actually the forces that must be overcome or broken during the melting, the evaporation, and sublimation. Okay, ito yung reason kung bakit kayang mag-transition ni water from the solid to the liquid and to the gas. Meron kasi tayong intermolecular forces of attraction na kailangang i-overcome or i-break down. Okay, para makapag-change ng phase ang water molecules. Okay? Now, Essentially, these forces of attraction determine the bulk properties of matter. Okay? At ito yung ating melting point and boiling point, which we will discuss later in this video. Now, you may be wondering, ano ba ang pinagkaiba ng intermolecular forces at intramolecular forces? Kasi di ba meron tayong inter at intra. So anong ibig sabihin niyan? Pag sinabi nating intermolecular, okay, from the word inter, these are actually the attractive forces between or among molecules. And they are generally weaker than intramolecular forces of attraction. Okay, they are easier to break. For the case of intramolecular, okay, so these are the forces that hold atoms within a molecule from the word intra, which means within. And an example of an intramolecular force is the covalent bond, okay, which is a type of bond that involves sharing of electrons among the atoms comprising the molecule. And because this force of attraction exists within the molecule, okay, they are relatively harder to break. Okay, so let's consider again the Lewis structure, okay, for the water molecule. So kung makikita ninyo, okay, in the molecule of water, meron tayong dalawang atoms of hydrogen and one atom of oxygen. Okay, and the way by which they are bonded together is through the covalent bond, which is an example of an intramolecular force. And sabi dito, for 1 mole of water, only 41 kilojoules of energy is needed to vaporize it. Okay? Pero, kinakailangan mo ng skyrocketing 927 kilojoules, okay, of energy to break the covalent bonds existing, okay, among the atoms comprising the water molecule. Okay? So again, intermolecular forces are the attractive forces between molecules. They are relatively easier to break than the intramolecular forces of attraction, which hold the atoms within a molecule. And an example of that is our covalent bond. For the case of the intermolecular forces of attraction, they are said to be electrostatic in nature. Pag sinabing electrostatic, okay, they involve the interaction of positive and negative charges. Okay? And sabi pa dito, the intermolecular forces of attraction decrease rapidly as the distance between the molecule increases. So habang humahaba, okay, ang distansya sa pagitan ng dalawang molecules, humihina ngayon yung intermolecular forces of attraction. Yun yung ibig sabihin nito. And IMFA or Imfa are important for solids and liquids daw. Okay? Why? Because these solids and liquids have a relatively compressed molecule arrangement. Okay? As compared to gases, okay, they relatively do not exhibit IMFA or they rarely exhibit IMFA due to the particles being spread out. So alam niyo naman yan from your elementary or high school science. Okay? So yun yan. Napunta na tayo sa different types of intermolecular forces of attraction. So we have here the van der Waals forces, okay? And this will include the London dispersion forces and the dipole-dipole forces. As you can see here, we actually have two types of IMFA, okay? This is the London dispersion force or London dispersion forces, and we have the dipole-dipole interactions. Now, these two are collectively referred to as the van der Waals forces, kagaya ng sinabi ko kanina. And as far as the dipole-dipole forces or DDF are concerned, meron tayong special type of DDF, okay? And that is your hydrogen bonding, okay? Meron din tayo actually tinatawag na ion dipole forces at dipole-induced dipole forces. Now, sir, bakit ganyan yung pagkaka-state mo ng mga terms na yan? Okay? Hindi lang po trip ni sir na mag-word art. Okay? May meaning yan. Okay? The thickness of the font actually has something to do with the strength of that particular intermolecular force of attraction. Okay? And kung makikita ninyo, ang pinakamakapal ang pagkaka-state ng font, okay, yung pinakamakapal na font ay yung hydrogen bonding. Because among these three types of intermolecular forces, okay, hydrogen bonding is the strongest. Okay, makikita niyo yan mamaya, okay, kapag tayo ay nagpatuloy sa ating discussion. Let's first define what London dispersion forces are. Okay? So, sir, bakit tinawag the London dispersion forces yan? So London po ba yan na-discover? The answer is actually no. Okay? This type of IMFA got its name because of a German physicist. Okay? And this is in the name of Fritz London, who first explained how noble gas atoms could be attracted to each other. Okay? That is during the 1930s. Now, London dispersion forces, or LDF, okay, in acronym, is a type of IMFA that is present in what? All substances. Okay? It is a type of IMFA na present sa lahat ng substances. Mapapolar man yan or non-polar. Okay? But it is the only intermolecular force of attraction that is present in what? Non-polar substances and noble gases. Pag sinabi mong non-polar, okay, ito yung mga molecules that have no net dipole moment. Okay? Kapag sinabing walang net dipole moment, these molecules, okay, will have dipoles that will just cancel out. Okay, so you have to review the supplementary material on Lewis structures provided to you. Okay, basta ang kailangan yung tandaan dito, pag London dispersion forces ang pinag-uusapan, ito yung type of IMFA na present sa lahat ng substances. Mapa non-polar man yan or polar. But for the case of the non-polar substances and noble gases, ito lang yung type of IMFA na present sa kanila. Okay? Now, London dispersion forces is actually a type of IMFA that is caused by what? Instantaneous dipole and induced dipole taken together. What is the meaning of instantaneous dipole? And what is the meaning of induced dipole? So sige, explain natin using this figure. Pag sinabi natin class na instantaneous dipole, okay, from the word instantaneous, okay, it means in an instant, okay? Pangmadalian lang. Parang kayo ng jowa mo. Joke lang. Okay. So, pero on a serious note, class, let's consider this figure that we have here. Let's say na yung shade of pink na meron dito sa molecule A and molecule B ay mga electrons. Initially, these electrons are well distributed, okay? They are uniformly moving in these molecules. Now, in an instant, may darating na point na yung electron density ng mga molecules na ito ay concentrated sa iisang side, just like the second figure for molecule A, okay? Because the electron density is on the left side, okay, it will temporarily have a partial negative charge. Because electrons are negative, tama ba? Because of this temporary development of partial charges, nagkakaroon ngayon ng temporary dipole. At ito yung tinatawag natin na instantaneous dipole. Now, dahil katabi ni molecule A si molecule B, nai-induce ngayon ni molecule A na magkaroon din ng temporary dipole si molecule B. At ito na ngayon yung induced dipole as seen in the last figure. Taken together, okay, ito na yung London dispersion force na tinatawag. Instantaneous dipole and induced dipole taken together. Okay, so shown here is figure 3A.1, which is also shown in your learning module 3. Okay, so this is also another illustration of how London dispersion forces exists, okay, between molecules. Now, ano yung mga kailangan nating tandaan as far as London dispersion forces are concerned? So sabi dito, London dispersion forces usually increase with molar mass of a substance. Okay? Sabi dito, the larger or the greater is the molar mass, the greater will be the strength of the London dispersion forces. The larger the molar mass, the bigger the atom is, okay, whose electrons are more distributed because the outer electrons are less tightly held by the nuclei. Okay? So, para magkaroon kayo ng mas malalim na appreciation about this statement, okay, let's first consider the following. Okay, so we have three molecules here. We have the nitrogen gas, the chlorine gas, and the fluorine gas. Also stated here in this slide, okay, are the molar masses for each of these molecules. Okay, now, all of these three are nonpolar molecules. Since that is the case, okay, they would only exhibit London dispersion forces. Now, how do we arrange, okay, these three molecules in terms of increasing strength of London dispersion forces? we will look at their molar masses. Sabi nga kanina, okay, the greater is the molar mass, the stronger will be the LDF forces, okay, or the London dispersion forces. And kung i-arrange natin to in terms of increasing strength of LDF, okay, ganito dapat yung maging arrangement niya. So as you can see, the nitrogen gas will be the weakest, okay, followed by fluorine gas. At yung pinakamatibay or pinakamalakas ang strength ng London dispersion forces ay yung ating chlorine gas. Okay, bakit? Kasi kung titingnan nyo yung kanilang mga molar masses, okay, malaki, okay, o pinakamalaki ang molar mass value natin for the chlorine gas. Okay, so that is how we interpret this data. Okay? Now, sabi dito, the strength of intermolecular forces of attraction operating between molecules is actually indicated by the physical properties such as the boiling point, the surface tension, and other physical properties of matter. Now, if you're going to look at this table, okay, this shows you, okay, the boiling points for the nitrogen gas, fluorine gas, and the chlorine gas. Now, how do we define the boiling point? The boiling point of a substance is actually the temperature at which the substance transitions from a liquid to the gaseous phase. And in order for us to change the state of a substance from liquid to gas, need natin mag-apply ng energy in the form of heat para ma-break natin yung interaction among the molecules. Now, how is IMFA related to boiling point? You have to remember that the stronger is the IMFA, the more na mahirap nating i-break, okay, ang interaction among the molecules. And the more na mahirap i-break yung interaction among the molecules, the more na kailangan mong taasan ang temperature in order for phase transition to occur. Okay? Ito yung dahilan kung bakit pinakamataas ang boiling point value for chlorine gas. Okay? Sabi natin kanina, siya yung may pinakamabigat na molar mass among the three. Okay? And sabi sa trend, the greater is the molar mass, the greater is the London dispersion force, okay, which is a type of IMFA. Dahil siya yung may pinakamalakas, okay, ang IMFA sa tatlo, siya ngayon yung molecule na mahihirapan tayong i-break yung interaction among their molecules. Okay, and because of this, we will be needing a higher, okay, temperature to break the interaction. Kaya mataas ang kanyang boiling point. Okay? I hope that is clear to everyone. So we're done with the London dispersion forces. Let's now proceed to the dipole-dipole forces. As compared to the London dispersion forces, so these dipole-dipole forces or DDF are present in polar molecules naman. Okay? Take note. In addition to LDF. Lagi niyong tatandaan na ang London dispersion forces ay present sa lahat ng substances. So in addition to London dispersion forces, okay, meron tayong dipole-dipole forces for the polar molecules as well. Okay? Sabi dito, the covalent bonds in the polar molecules behave as if the bonded atoms have localized partial opposite charges, creating a dipole. Okay? Compared to the nonpolar molecules, the polar molecules have a permanent dipole. Hindi instantaneous. Okay? It is permanent. In addition, may net dipole moment ang mga polar molecules natin. If these dipoles do not cancel each other, the net dipole moments align together so that a positive end interacts with a negative end of another. And the more polar the molecule is, the stronger is the dipole-dipole force. Now, meron tayo ditong illustration, okay, ng mga Lewis structures ng dalawang magkaibang molecules. Okay? We have here the Lewis structure for carbon dioxide, which is non-polar. Okay? And we have an illustration of a molecule that is polar. Now, kung ating re-reviewin yung Lewis structures, okay, we can draw the Lewis structure of carbon dioxide like this. Okay? And as you can see here, meron tayo dito mga dipoles na dinrawing. Okay? Anong ibig sabihin yan? Itong dipole arrows na ito ay drawn such that the head of the arrow will point towards the more electronegative element, okay? At yung tail niya ay nandoon sa posisyon ng less electronegative element. Ano ba ang ibig sabihin ng electronegativity? Electronegativity is the ability of an atom or an element to attract shared electrons toward itself. Take note that in this type of illustration, the carbon and the oxygen shares electrons. Okay? And since oxygen is more electronegative, mas kaya niyang hilahin yung electron density papunta sa kanya. Okay? Which makes it partially negative. And because of this, okay, the dipole arrow will point papunta sa oxygen, okay, thereby creating a dipole moment. Pero take note, ganito natin dinodrawing ang Lewis structure for carbon dioxide. Since meron tayong carbon-oxygen double bond sa magkabila, okay, sa magkabilang side ng ating illustration, okay, pwede nating i-draw yung mga dipole arrows in the opposite sides, okay? So kapag ganito yung pagkakadraw natin sa mga dipole arrows, they will just eventually cancel out, okay? If ipag-a-add natin itong dalawang to. Since nag-cancel yung dalawang dipole arrows, okay, we can say na walang dipole moment itong ating carbon dioxide, making it a non-polar molecule. Since it is non-polar, the only type of IMFA that is present is only the London dispersion force. Okay? Kumpara natin dito sa molecule na to. Kung mapapansin nyo, okay, meron tayo ditong permanent partial negative at partial positive charges. And because they have permanent partial charges, it will have a net dipole moment. At kapag may net dipole moment, ibig sabihin, polar yung molecule. At kapag polar ang molecule, okay, ang type of IMFA na present ay London dispersion force at dipole forces. Okay? So you have to remember that. And sabi pa dito, the more polar the molecule is, so the more na polar yung molecule, the more na malakas ang dipole force na meron siya. Okay? Another illustration of the dipole force, okay, is in this figure. Okay, kung papansin nyo, we have a molecule of hydrochloric acid here. Okay, between the hydrogen and chlorine, mas electronegative si chlorine, so siya yung magkakaroon ng partial negative charge. Okay, because the electron density ay mas napupunta sa kanya. Because of this, meron tayong development ng permanent dipole. And as you can see, pag meron tayong dalawang HCl molecules dito, the partial negative end of one molecule will be attracted now to the partial positive pole or partial positive end of another molecule. Ito yung tinatawag natin na dipole forces. Okay? Attraction between two polar molecules. Okay? Another illustration. So this is another way of representing the dipole forces, okay, existing among HCl molecules. Okay? And you have to remember that the more polar the molecule is, okay, the more na mataas or malakas ang kanyang dipole forces. Now let's consider this series. So we have hydrochloric acid, HCl. We have hydrobromic acid or HBr or hydrogen bromide. And we have hydrogen iodide or hydroiodic acid. Okay? Sabi dito, in terms of polarity, we can arrange them like this. Okay? Bakit kaya? Look at this periodic table. In your Chem 18 lecture, madidiscuss doon yung trends in atomic properties. And in this particular periodic table, meron tayong mga behavior na tinitingnan. And one of them is electronegativity. Okay? Like I've said earlier, electronegativity is a measure of an atom's ability, okay, to attract shared electrons toward itself. And sabi, when you go from left to right across the periodic table, tumataas daw ang electronegativity. And going from the bottom position to the top of the periodic table, tumataas din ang electronegativity. So pwede nating i-represent yung trend like this. Okay? In going from bottom to top, tumataas ang electronegativity. Same with, okay, kapag pumunta ka from left to right across the periodic table. Okay? And kung titingnan natin ang electronegativity ng chlorine, ng bromine at ng iodine dito sa position na to, okay, makikita natin na sa kanilang tatlo, pinaka-electronegative si chlorine. Because of this, okay, pinakamataas ang ability ni chlorine to attract shared electrons toward itself. So mas magiging polar ngayon ang molecule ng HCl. Okay, yung pinakita natin kanina. Since HCl is the most polar, siya ang may pinaka malakas ang DDF, okay, or yung dipole-dipole forces. Okay? So I hope that's clear. Let's have a practice, okay? Let's try to identify the type of IMFA na present sa mga following substances. So we have letter A, methane. We have the argon, okay? We have HBr. We have carbon dioxide or CO2. We have the bromine, okay? So ang task ninyo is to determine what type of IMFA ang present sa 5 molecules or atoms nito. Okay? So you may pause this recording para masagutan nyo to. Then after nyo masagutan, pwede nyo nang i-play para ma-reveal yung tamang sagot. So if we're going to identify the IMFA present among the following substances, you will know that methane, letter A, okay, is nonpolar. Because methane is nonpolar, the only type of IMFA na present sa kanya ay yung London dispersion forces. Okay? For the case of argon, okay, kung ilolocate natin si argon sa periodic table, it will be located under the noble gases. And since noble gas yan, okay, we can say that the only type of IMFA na present ay London dispersion force. Okay? Next, we have letter C, hydrobromic acid or HBr. Kung makikita ninyo, okay, bromine is more electronegative than hydrogen. It will create a partial negative and partial positive pole, okay, in the molecule, okay, making it a polar molecule. Since it is a polar molecule, okay, aside from London dispersion forces, it will also have dipole forces. Next, we have letter D, carbon dioxide. Alam natin kanina that carbon dioxide is a nonpolar molecule. Since it is nonpolar, the only type of IMFA na present ay London dispersion force lang. Okay? Same with bromine gas, okay, sa letter E. Kasi ito ay non-polar din. Okay? So I hope tumama kayo sa inyong mga sagot. Next practice, okay? You are to arrange the following non-polar molecules in terms of increasing strength of IMFA. O ayan, may clue na kayo sa instruction. All of them are non-polar. So saan na lang sila magkakatalo? Okay? Sa molar masses. Okay? And sabi natin kanina, the greater is the molar mass of a substance, the greater will be its intermolecular force of attraction. At anong type of IMFA yon? London dispersion forces. So you may pause this recording, okay? Then kapag may sagot na kayo, you may resume playing the video para ma-reveal yung answer. Okay, you may use the symbols greater than, less than, or equal, okay, if you want to. Now, if you're going to arrange the following nonpolar molecules in terms of increasing, okay, strength of IMFA, ito dapat yung maging sagot ninyo. Okay? So, BF3 or boron trifluoride, okay, is the weakest, okay, followed by SF6 or sulfur hexafluoride. When we have here CCl4 or carbon tetrachloride, then we have Br2. And then lastly, yung may pinakamalakas na IMFA or London dispersion force, to be specific, ay yung ating iodine gas. Why? Because among all of these molecules, siya yung may pinakamataas ang molar mass. And the greater is the molar mass, the greater will be the London dispersion forces. Okay? I hope that is clear to everyone. Okay, so practice number 3. So let us predict which substances in each of the following pairs would have a stronger IMFA. So dito sa table na to, ang kailangan yung pag-compare ay si CO, CO2, si CH, Cl3 at saka si CCl4, basta yung magkatapat. Okay? So you may use greater than, less than, or equal na symbols, okay, para ma-predict ninyo, okay, yung or para mapag-compare ninyo yung dalawang molecules natin. Okay? So, pwede nyong i-pause to, then saka kayo magsagot. Now, if you're going to compare, okay, there's their IMFA strength, okay, between carbon monoxide or CO and carbon dioxide, okay, mas malakas ang IMFA ng carbon monoxide. Bakit? Between carbon monoxide and carbon dioxide, okay, carbon monoxide is actually polar, while carbon dioxide is only a nonpolar molecule. Okay? Since carbon monoxide is polar, okay, aside from LDF, meron din siyang dipole-dipole forces. Okay? Next, we have CHCl3 or chloroform, and we have carbon tetrachloride. The answer here should be greater than. Okay? So, yun yung sagot natin. Why? Because chloroform is polar, while carbon tetrachloride is not. Next, between HCl and HI, so alam na natin to kanina, HCl will have a greater, okay, strength of IMFA. And between the last two molecules that we have here, okay, between hydrogen gas and nitrogen gas, which are actually non-polar molecules, so magkakaroon na lang sila sa molar masses nila. Since mas mabigat, okay, or mas malaki ang molar mass ng nitrogen gas, we can say that it has a stronger IMFA. Okay? So I hope tama ang ating mga naging sagot. Okay. So now we're done discussing London dispersion forces and dipole-dipole interaction or dipole-dipole forces. We now proceed to the special type, okay, of dipole-dipole force, and that is our hydrogen bond. Okay? So hydrogen bond, according to this slide, is present among molecules wherein the hydrogen atom is bound to a highly, okay, electronegative element like fluorine or F, oxygen or O, and nitrogen or N. Okay? So meron ako ditong mnemonic. So you may use the mnemonic HIFON, okay? HIFON, okay? Para malaman ninyo or para matandaan ninyo kung ano lang ba ang mga valid na molecules na merong hydrogen bonding sa kanilang interactions. Okay? Sabi dito, a hydrogen atom is bound, okay, to one highly electronegative atom, NOF, okay, in one molecule, and is simultaneously attracted to a highly electronegative atom in another molecule. Now, here are the typical compounds that will exhibit hydrogen bond. So meron tayo ditong mga molecules kung saan yung ating hydrogen ay bound, okay, to oxygen. Okay? Meron din tayo ditong molecule kung saan yung hydrogen is bound to nitrogen. At yung isa naman ay hydrogen being bound to fluorine. So kapag nakita nyo itong mga ganitong klaseng bonding, okay, sa mga molecules, we can say that that molecule is capable of hydrogen bonding. Now, one example of a molecule that is capable of hydrogen bonding is the water molecule. As you can see here, okay, sa kanyang structure, the hydrogen is covalently bonded, okay, to a highly electronegative element. And that is oxygen. Ano ba yung ating criteria para masabi natin na capable of hydrogen bonding ang molecule? Dapat yung hydrogen ay covalently bonded sa nitrogen or oxygen or fluorine. Since the hydrogen here is covalently bonded to oxygen, pasok siya sa ating criteria, okay? Making the water molecule capable of hydrogen bonding. Now, this figure shows you, okay, how hydrogen bonding exists among water molecules. Sabi natin kanina sa isang slide, okay, a hydrogen atom is bound to one highly electronegative atom, okay, for which this case is oxygen, okay, in one molecule. And this molecule, okay, this hydrogen atom in one molecule is simultaneously attracted to the highly electronegative atom. So it is clearly seen here. As you can see, meron tayo ditong isang water molecule. Yung hydrogen itong water molecule na to ay attracted sa oxygen, okay, ng isa pang water molecule. Okay, this is how we illustrate the statement in the previous slide. Okay, so this is one example of a molecule capable of hydrogen bonding. So this is another example, okay, of water molecules, okay, exhibiting hydrogen bonding among them. Okay? So ang kailangan nyo lang tandaan dito kapag ang pinag-uusapan ay hydrogen bonding at titingin kayo ng molecule na capable of hydrogen bonding, ang kailangan nyo lang tingnan is if meron bang hydrogen na covalently bound, okay, to F, O, or N. Okay? At para ma-practice kayo, let's try to answer the following. So which of the following substances will exhibit hydrogen bonding among themselves? So we have the following examples. Okay, we have methane. Okay, letter A. Letter B, HI. Letter C, we have methanol. Okay. Letter D, we have this molecule. Ang tawag po dito ay methylamine. Okay. And we have letter E. So organic chemistry, ang tawag dito ay dimethyl ether. Okay? So you will have to predict, okay, alin ba dyan sa mga yan ang capable of hydrogen bonding among themselves. Okay? Kailangan lang tandaan nyo dito na para masabi ninyo na yung molecule ay capable of hydrogen bonding, dapat makita nyo sa kanyang structure yung hydrogen that is covalently bound to nitrogen, oxygen, or fluorine. So you may pause, okay, this video para sagutan ninyo, okay, itong tanong na to. And then kapag may sagot na kayo, resume playing para ma-reveal yung tamang sagot. So ang tanong dito is that, alin ba dito sa mga substances, okay, yung mag-i-exhibit ng hydrogen bonding among themselves? So ang sagot dito, class, is actually letter C. Okay? So kung makikita ninyo, the oxygen is covalently bound to hydrogen. Okay, this hydrogen is bound to a highly electronegative atom, okay, such as oxygen. Because of this property, we can say that this molecule is capable of hydrogen bonding. Another one is this one, okay, itong methylamine natin. Kung makikita ninyo, the hydrogens here are covalently bound to nitrogen, which is also a highly electronegative element. Okay? So kapag tandaan nyo yung criteria na yon, hindi kayo mahihirapan na pumili kung alin ba sa mga molecules na nakabigay, okay, yung capable of hydrogen bonding. Okay? So yun lang naman. Next, which of the following correctly illustrates hydrogen bonding? O ito, na-describe na natin to kanina. Sabi natin, okay, for hydrogen bonding to occur, dapat yung hydrogen doon sa isang molecule, okay, should be attracted to the highly electronegative atom of another molecule. Okay? Provided na yung hydrogen na yon ay covalently bound to a highly electronegative element. Okay? So you may start answering this. Okay? Pause nyo muna tong video recording. Then reveal nyo yung tamang sagot. Okay? By resuming it. So if we are to choose, okay, alin ba dito yung tamang illustration for hydrogen bonding? The answer should be letter B. Okay? Bakit hindi pwede si letter A? Ang sabi lang natin kasi, okay, in order for hydrogen bonding to happen, dapat yung molecule natin ay may hydrogen that is bound to FOM or HEFON. Okay? Since hydrogen here is bound to chlorine, okay, and wala naman siya dun sa tatlo, so, X na to kaagad. Okay? What about letter C? Eh sir, diba? Meron naman tayo ditong hydrogen that is bound to nitrogen, which is a highly electronegative element. Eh yung interaction kasi dito sa letter C ay mali. Okay? The interaction is between two nitrogen atoms. Okay? Which is not the correct way to illustrate hydrogen bonding. Okay? Sa letter B kasi, ito na yung tamang illustration natin for the hydrogen bonding. Why? Because as you can see here, the hydrogen is covalently bound to oxygen. Okay? At itong hydrogen na to, it is actually attracted to the oxygen of another molecule, kung saan meron ding naka-covalently bound na hydrogen sa kanya. Okay? So this is how we correctly illustrate hydrogen bonding between molecules. Okay, so I hope that is clear to everyone. Okay, so at this point, we're done discussing the types of intermolecular forces of attraction. So, na-discuss na natin yung London dispersion forces, dipole-dipole forces, at yung special type of dipole-dipole force, which is hydrogen bonding. Now, this section discusses the strength of van der Waals forces. Ano ba ang dapat nating malaman, okay, as far as the strength of the van der Waals forces are concerned? Now, sabi, physical properties are strongly influenced by the strength of the van der Waals forces, okay, which is the collective strength of their London dispersion forces and dipole-dipole forces. Now, let's consider HCl and HBr, hydrochloric acid and hydrogen bromide. Kung makikita ninyo, HCl has stronger, okay, dipole-dipole force. Okay, because comparing HCl and HBr, okay, the chlorine in HCl is more electronegative. So since mas electronegative si chlorine kaysa kay bromine, okay, mas polar ngayon yung HCl. Kaya mas malakas ang kanyang dipole-dipole force. Okay? But, okay, for the case of HBr, it will actually have a stronger London dispersion force. Because if we're going to compute for the molar mass, okay, of the two, makikita ninyo na mas mabigat or mas malaki ang molar mass ng HBr compared kay HCl. And because that is the case, it will have a stronger London dispersion force. Now, medyo nagkakatalo. Okay? Medyo nagkakaroon tayo ng dilema pagdating dito. So, ang magiging tanong natin siguro, which of the two has stronger van der Waals forces? Kasi yung isa may stronger dipole-dipole force because of the electronegativity of the chlorine. Okay, yung isa naman, mas malaki yung London dispersion force because it has greater molar mass. Now, alin sa dalawa yung mas matibay or mas malakas ang van der Waals forces? Okay, which will have a higher boiling point. So in assessing which substance will exhibit a stronger van der Waals forces, okay, we can actually follow, okay, these guides. So sabi sa slide na to, if the substances being compared have widely different molar masses, okay, London dispersion forces will be considered more important than dipole-dipole interaction. Okay? Ang kondisyon, okay, dapat daw, pag meron kang dalawang substances sa pinagko-compare, okay, if they have widely different molar masses, London dispersion force ang ating magiging basihan, okay, sa pagkumpara ng strength ng kanilang IMFA. Pero sabi sa second statement, if the molar masses are relatively, okay, near each other, okay, the presence of dipole-dipole interaction would greatly contribute to the strength of their intermolecular forces of attraction. Okay? So, pasimplihin natin. Kapag meron kang dalawang substance na pinagko-compare, tapos itong dalawang substance na ito ay sobrang magkaiba or sobrang magkalayo ang molar masses, London dispersion force ang ating i-consider. Pero, kapag meron kang dalawang substances na pinagko-compare at ang kanilang molar masses ay magkalapit lang, okay, magkakatalo na lang sila sa kanilang polarity. Okay? So, kung sino man sa kanila ang mas polar, edi mas mataas ang dipole-dipole force. At yun yung magko-contribute sa strength ng kanilang intermolecular forces of attraction. Okay? Yun lang yun. Now, we actually have four more, okay? Four more guides, okay, in comparing the strength of van der Waals forces. So, in assessing which substance will exhibit a stronger van der Waals force, okay, number one, if one of the substances being compared only exhibits London dispersion forces, while the other exhibits dipole-dipole interaction, the London dispersion force will predominate kung yung molar masses, okay, or yung molar mass ng non-polar substance is at least 2 times larger, okay, than the molar mass of the polar substance. Ibig sabihin lang nito, kapag meron kang dalawang substances sa pinagko-compare, yung isang substance ay LDF lang, tapos yung isa merong dipole-dipole interaction, magpipredominate lang ang London dispersion force kapag yung molar mass ng non-polar na substance ay doble, okay, ng laki kumpara doon sa substance na polar. Okay? I hope that's clear. Second guide, okay? If one of the substances being compared only exhibits LDF, while the other exhibits hydrogen bonding, which is a type of dipole-dipole force, LDF will predominate kung yung molar mass ng non-polar substance is at least 6 times larger than the molar mass of the polar substance. So meron kang dalawang substances na pinagko-compare. Yung isa non-polar, so LDF lang ang kaya niyang interaction. Yung isa naman ay kaya ng hydrogen bonding. Now, paano matatalo ng LDF yung hydrogen bonding? LDF will predominate kung yung molar mass ng non-polar substance ay 6 times larger kumpara sa molar mass ng substance na capable of hydrogen bonding. Okay, yun lang yung ibig sabihin ng statement number 2. Guide number 3, okay? If the two substances are polar, okay? So dalawang substances pinagko-compare mo, polar parehas, but only one of these substances exhibits hydrogen bonding, okay? Dipole-dipole interaction will predominate kung, okay, yung molar mass ng substance that does not exhibit hydrogen bonding is at least 3 times larger, okay, than the molar mass of the other substance. So meron kang dalawang substances na pinagko-compare dito sa guide number 3. Yung isa, okay, hydrogen bonding, may hydrogen bonding. Yung isa naman, polar siya pero dipole-dipole interaction lang ang kaya niya. Okay? Now, yung dipole-dipole interaction yung magpipredominate daw kung yung molar mass ng substance na walang hydrogen bonding ay 3 times larger. Okay? Yung molar mass niya kumpara doon sa substance na capable of hydrogen bonding. Okay? Yun yung number 3. For number 4, if both the substances being compared exhibit hydrogen bonding, London dispersion force will predominate kung yung molar mass ng larger molecule is 2 times larger, okay, than the molar mass of the smaller molecule. So meron kang dalawang substances na pinagko-compare sa number 4. Okay? Both of them exhibit hydrogen bonding. Now, paano natin mapagkukumpara yung dalawang molecules kung pareha silang capable of hydrogen bonding? Magkakatalo na lang sa molar mass. So the greater is the molar mass, okay, the greater will be the hydrogen bonding of that molecule. Okay? So yun yung ibig sabihin ng statement number 4. Now let's try to evaluate this table. Okay, this table shows you the different substances. We have the fluorine gas, nitrogen gas, okay, NOCl or nitrogen oxychloride. We have the chlorine gas and we have the carbon tetrachloride. Given din dito sa table na to yung kanilang mga molar mass values, okay, and yung kanilang corresponding boiling points. Okay, anong mapapansin nyo sa table na to? Okay, if you can see here, fluorine ay 38 grams per mole, nitrogen ay 28.02 grams per mole ang molar mass. Among all of the substances stated here, okay, ang may pinakamalaking molar mass ay itong carbon tetrachloride, 153.82 grams per mole. As you can see in the table, since the difference in the molar masses ay wide, okay, the substances having the larger molar masses will exhibit stronger van der Waals forces, okay, as indicated by higher boiling point values. Okay? Since pinakamalaki ang molar mass ng carbon tetrachloride, okay, at dahil sobrang magkakalayo ng kanilang mga molar mass values, okay, naging predominant ngayon, okay, yung LDF. Kaya mataas ang boiling point natin for carbon tetrachloride. Now, let's consider nitrogen oxychloride and chlorine gas. Okay? So as you can see, they have comparable molar masses. Sobrang magkalapit lang ng molar mass ng dalawa. Yung isa 65.46, yung isa 70.91 grams per mole. Now, kung makikita ninyo yung kanilang boiling points, masasabi ninyo na mas malaki ang boiling point ng nitrogen oxychloride compared kay chlorine gas. Magkalapit lang naman ang kanilang mga molar masses. Take note that nitrogen oxychloride has a higher boiling point, which may be attributed to the dipole-dipole interaction that is present in nitrogen oxychloride. Di ba nga, sabi natin kanina, kapag meron tayong dalawang substances na pinagko-compare, okay, tapos magkalapit lang ang kanilang mga molar masses, magkakatalo na lang ngayon sa polarity, okay, yung ating magiging comparison. Since nitrogen oxychloride is a polar substance, chlorine gas is non-polar, we can say that nitrogen oxychloride has a greater, okay, strength of intermolecular force of attraction. Kasi nga, polar siya, so aside from LDF, meron pa siyang dipole-dipole forces of attraction, okay, which attributed to the boiling point value. Okay? So yun yung interpretation natin sa table na ito. Let's have a practice. Okay, so you are to match the boiling point with the substance. So we have the different substances here. Okay, meron din tayong mga molar mass values. And nandito yung mga possible boiling points ng apat na substances na ito. So you are to match the boiling point with the substance, okay, given the data that we have here, okay, and the molecular formula, okay, na meron sila. So you may pause this recording, sagutan nyo to, then resume playing kapag may sagot na kayo. So if we are to match the boiling point with the substance, so the first one, okay, the first substance will have 36 degrees Celsius as its boiling point. Okay, bakit? Kasi ito yung may pinakamaliit na molar mass. Okay, next. The last substance, okay, will have 156 degrees Celsius as its boiling point. Bakit? Kasi siya yung may pinakamalaki ang molar mass. Now, as you can see, for the second and the third substance, comparable ang kanilang mga molar masses. Okay? Since comparable ang kanilang mga molar masses, they are relatively near each other. So, titingnan na lang natin dito kung alin sa dalawa ang mas polar. And apparently, okay, the second compound is more polar as compared to the third compound. That is why, okay, the third compound will assume 126 degrees Celsius as its boiling point, and the second compound will have 132 degrees Celsius as its boiling point. Okay, so this is how we answer this problem. Next practice. So the compounds bromine gas, okay, and iodine chloride, okay, have the same number of electrons. Yet Br2 melts at negative 7.2 degrees Celsius, whereas ICl melts at 27.2 degrees Celsius. You are to explain. Okay? So, pwede nyo sagutan to by pausing the video first. Then kapag may sagot na kayo, resume playing para ma-reveal yung correct answer. Okay? So, ano kaya yung explanation kung bakit ganito yung behavior ng dalawang substances natin? It is because bromine gas is non-polar. Therefore, it will only exhibit London dispersion forces. ICl is a polar substance, hence it will exhibit dipole-dipole forces and London dispersion forces. Since that is the case, ICl will have a higher melting point. Ganun lang kasimple ang explanation. Okay, so that's it. Next, we proceed with isomers. So, kailangan nating malaman kung ano ba ang ibig sabihin ng isomers at how these isomers are related, okay, to the Imfa or the strength of the intermolecular forces of attraction. So, isomers are defined as compounds of the same molecular formula but they differ on their chemical structures. Okay? So, ito po yung definition natin ng isomers. Mas ma-define nyo ito ng maayos when you go to organic chemistry. Okay, ang tinitingnan lang natin dito is, ano ba ang effect, okay, kapag meron kang isomers sa strength ng intermolecular force of attraction. So let's say we have the two compounds here. We have one bromopropane, okay, with this particular structure, and two bromopropane. Okay, as you can see here, okay, both of them have 1, 2, 3 carbons in its structure. 1, 2, 3, 4, 5, 6, 7 hydrogens for 1 bromopropane and 1, 2, 3, 4, 5, 6, 7 for 2 bromopropane. Meron din silang tig-isang, okay, bromine sa kanilang structure. So basically, they have the same molecular formula. Okay? Meron silang C3H7Br. Okay? Parehas ganon yung kanilang molecular formula. But as you can see in their chemical structures, magkaiba sila. Okay? Making them isomers. Now, ano ang kahalagahan? Okay, na malaman ang chemical structures ng mga yan. So, i-reveal natin mamaya. Okay, another set of isomers that we have is the diethyl ether and 1-butanol. Okay? So, bakit isomers tong dalawang to? Tingnan natin yung component atoms nila. For diethyl ether, meron tayong 1, 2, 3, 4 na carbons. For 1-butanol, we have 1, 2, 3, 4 carbons as well. Okay? What about the number of hydrogens? For diethyl ether, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. For 1-butanol, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So 10 hydrogens din. So C4H10 na. Okay? Tapos dito sa diethyl ether natin, meron tayong isang oxygen, okay? Same here for 1-butanol. So ang kanilang molecular formula ay C4H10O, parehas. But as you can see, magkaiba ang kanilang chemical structures. Now ano kaya ang epekto, okay, ng pagkakaiba nito sa kanilang physical properties, okay, at sa kanilang IMFA strength? Sabi dito, linear compounds have a greater surface area than their branched isomers, which results to closer contact with other molecules. Therefore, yung linear compounds natin for the isomers ay mas mataas ang London dispersion force, or basically mas mataas ang kanilang IMFA. As you can see in the structures of 1-bromopropane and 2-bromopropane, makikita nyo na mas linear ang structure ng ating 1-bromopropane. Okay? So kung magdodrawing ka dito ng isa pang molecule ng 1-bromopropane, okay, marami ka ritong sites of interaction, okay, between the two. Kumpara dito sa 2-bromopropane na medyo spherical ang shape, okay, kapag dinrawing natin, okay, and if we're going to draw another molecule of 2-bromopropane, mas konti lang yung sites of interaction ng dalawa. Okay? So, ibig sabihin, the more na linear yung compound mo, okay, sa isang given set ng isomer, the more na mas maraming sites of interaction among them, okay, resulting to greater interaction among the molecules. Okay? Kaya mas mataas ang IMFA. Okay? And this is seen by their boiling points. Okay? As you can see, the boiling point of 1-bromopropane is 71 degrees Celsius, kumpara sa boiling point ng 2-bromopropane which is 59 degrees Celsius. Okay? So the more na linear ang structure ng ating isomer, the more na mataas ang interaction among them, the greater is the IMFA. Okay? So yun yun. Another thing that you need to look at is the functional groups, okay, na present sa mga isomers natin. So yung functional groups po sa organic chemistry, mas madidiscuss nyo to. Okay, pero itong functional groups na tinutukoy ay yung specific group, okay, na siyang magkukos ng certain reactivity ng isang compound. Now, if we're going to compare diethyl ether and 1-butanol, okay, masasabi natin na LDF lang, okay, ang kayang i-exhibit ng diethyl ether. As compared to 1-butanol, if we're going to look at the structure, makikita nyo dito na meron tayong hydrogen that is covalently bonded to oxygen, which is an electronegative element. And because there is this feature in the structure, we can say that 1-butanol is capable of what? Hydrogen bonding. Okay? So ito yung kailangan ninyong tandaan dito. Okay? So if we have isomers, okay, with different functional groups, titingnan nyo dito sa kanila kung alin ang mas capable of having a more polar, okay, interaction, okay, with molecules. Titingnan nyo kung alin dito sa dalawa yung mas capable of interacting through dipole-dipole force or hydrogen bonding. And apparently, between the two, okay, 1-butanol exhibits hydrogen bonding because of this feature in their structure. Okay, and because of this, mas mataas ang Imfa ng ating 1-butanol compared to diethyl ether. Okay, so that's it. Now, so paano ba tayo makakapag-decide, okay, kung paano natin makapag-compare, okay, yung strength ng IMFA ng isang molecule sa another. Okay, so we have here a decision flow chart for determining the IMFA. So the first question that you will need to ask is that, are polar molecules involved? Kapag walang polar molecules na involved, edi kailangan mong tingnan yung kanilang London dispersion forces. Okay? At sa London dispersion forces, nagkakatalo tayo dito sa molar mass. The greater is the molar mass, the greater is the London dispersion force. Kapag may involved na polar molecules, okay, titingnan mo ngayon yung second question. Are hydrogen atoms bonded to O, F, or N? Or meron bang feature, okay, doon sa molecule na makakapag-enable sa kanya, okay, na makipag-hydrogen bond? Kapag wala, edi dipole-dipole force ang meron siya. Kapag meron, edi that molecule exhibits hydrogen bonding. Okay? So isa to sa mga pwede nyong gamiting guide, okay, in deciding, okay, the type of IMFA na present dun sa mga molecules na yun. Okay, so I hope that's clear. Now, we go to the last part of our discussion for Imfa. Okay, as you can see here, we have physical properties of matter that are affected by the strength of IMFA. And we will be starting by discussing the heat of vaporization. So heat of vaporization is actually defined as the amount of heat for a given amount of liquid to change to gas at constant pressure. Ito raw yung energy na kakailanganin mo para makapag-transition yung substance from liquid to gas. And sabi, the stronger is the IMFA, the greater or the higher is the heat of vaporization. Which makes sense. Kasi kapag mataas or kapag matibay ang intermolecular force of attraction among the molecules of a particular substance, the more na mahirap mong i-break yung kanilang interaction. And because our goal is to transition, okay, the phase from liquid to gas, kailangan nating i-break yung interaction na yon. And the more na matibay ang interaction, the more na mataas na energy ang kailangan mong i-supply. Hence, higher heat of vaporization. The same is true for the heat of fusion, okay, which is yung energy na kailangan mo para ma-transition mo yung phase ng substance from solid to liquid at constant pressure. Okay, so the stronger is the IMFA, the higher will be the heat of fusion requirement. Next physical property is the viscosity, okay, the resistance of a liquid to flow. Pag sinabing viscosity sa Tagalog, edi yung lapot, okay, ng mismong liquid substance. Okay? And sabi dito, the stronger is the IMFA, the higher will be its viscosity. Because of the greatness, okay, of the interaction among the molecules, okay, mahirap nga yung i-break yung kanilang interaction. And because of this property, mas nagre-resist ngayon, okay, yung ating liquid to flow. Okay? Kaya mas mataas ang viscosity. Next, we have the vapor pressure. Okay, so the vapor pressure is defined as the pressure exerted by a gas on the surface of its liquid form in a closed container. Okay, sabi dito, strong IMFA, okay, mas mahirap i-escape, okay, into gaseous state. Okay, mas mahirap para sa liquid molecules to escape into the gaseous state, the lower will be the vapor pressure. Okay, next we have the surface tension. Surface tension is the energy needed to increase the surface area of a liquid by 1 unit. Okay? And the stronger is the IMFA, the higher will be the surface tension. Okay? So ito lang naman yung kailangan yung tandaan dito. Mas may explain pa natin to when we have our post-lab discussion. Pinadaanan lang natin itong mga physical properties na ito. So this ends our discussion for the intermolecular forces of attraction. So if you have further clarifications or questions, do not hesitate to contact me. Okay, so thank you class for listening.